In this video, we're going to look at complex numbers. We're going to look at that italicized I. So we're going to look at what is an imaginary number, why do we have them, how do we use them, and then how do we do math with I. So to start out with, what are complex numbers? So complex numbers are a combination of a real part with an imaginary part. So if you look over here to the right, you will see all of the things that make up real numbers. Generally, that's this part of our imaginary number. And then we have the imaginary part, which is usually a coefficient times the italicized I. And that italicized I is equal to the square root of -1. So why imaginary numbers? So imaginary numbers were first used in the 16th century to help find the solution to cubic equations. The first written name calling them imaginary numbers was by Gauss in 1832, and they help us solve problems when we have to take the square root of a negative number. So we have to be careful when we talk about imaginary or solutions, especially to quadratics and radicals, as no solution, because it's not no solution. It's no real solution. There are imaginary solutions to it. And if we look here to the right, the way our complex number looks on a graph is instead of x and y, you have a real axis and an imaginary axis. So working with I, so if we want to take the square root of -80, so 80 is 8 and 10, which is 2 and 5, and this is 2 and 2 and 2. So this is 4 2's and a 5. So the square root says we can pull out 4, and it's the square root of -5. So we would say that this is 4i square root 5. If you look at the other one, our other example, 25 is a perfect square. So we know the square root is 5, but we have that negative, so it's going to be 5i. Because in that radical, it's 5 times -1. Square root of -1 is I, and then the square root of 25 is 5. So that's working with I. Now, operations with I. I, in essence, kind of works like a variable. So we can clear those first parentheses. We have to distribute that negative. And now it's a matter of combining like terms. You end up with -2, combining those two. And then when we combine these two, we get -2i. So, and that's a complex number in standard form. The real part first, followed by the imaginary part. When we have binomials, when we're doing multiplication, it's just as if it was a variable and we were going to do the distributive property. So this one is going to be 12 minus 24i minus 3i. And then this is going to be minus 6, because I times I is -1. Remember, I is the square root of -1 times the square root of -1 gives us -1. So from here, we just simplify. This is going to be 6 minus 27i. Multiplying with I. So when doing division with I, you have to use something called the complex conjugate. And the complex conjugate is, for this particular one, is instead of 4 plus 2i, we're going to multiply top and bottom by 4 minus 2i. So then we simply have a binomial in the bottom. So this ends up being 16, and it's a perfect square, or a difference of squares. So it's 16 plus 4, because 2i times 2i is negative 4, and then it's the negative 2 there, so that's that. And then the numerator, so we have negative 4i plus 2i squared. So we get negative 2 minus 4i, flipped it around into standard form, divided by 20. And then we can simplify a little bit. The factors of 2's all around, so we have negative 1 minus 2i all over 10. And then to write in our standard form, it would be negative 1 over 10 minus 1 over 5i. Simplified it there. So that's division with imaginary numbers. So in this video talking about imaginary numbers, we looked at what it is, why we have them, how to use them, and then how to perform the basic operations: add, subtract, multiply, and divide with imaginary numbers.